Hydrogen is the most common thing in the whole universe. Think about that for a second. It is also the simplest element there is. A single hydrogen atom has just one proton and one electron. That's it. It is number one on the periodic table for a reason. Here on Earth, hydrogen doesn't like to hang out by itself. It's a social element. It usually pairs up with another hydrogen atom. That forms a molecule of hydrogen gas, H2. This gas is incredibly light. So light it will float up and away if not contained. It's completely invisible. It also has no smell, so you wouldn't even know it was there. So, why are we talking so much about this simple invisible gas? Well, hydrogen has a very special property. It can store and carry energy. It's not an energy source like the sun. When you hear hydrogen, you might think of the Hindenburg airship. But hydrogen's uses today are far more advanced and a lot safer. The vast majority of hydrogen produced right now is used behind the scenes in big industries. One of its main jobs is in making ammonia for fertilizer. That fertilizer helps grow the food that ends up on our plates. Oil refineries also use a lot of hydrogen. They use it to remove sulfur from gasoline and diesel, making fuel cleaner and reducing air pollution. It's used in making margarine, in steel manufacturing, and in electronics production. But the uses that are getting everyone excited are the new ones. Imagine trucks, buses, ships, all powered by hydrogen and emitting only water vapor. This is happening right now. These vehicles use a fuel cell. Fuel cells take in hydrogen and oxygen and convert them via a chemical reaction into electricity to power a motor. No combustion, no noise, no pollution. Big advantage over batteries. Refuel in minutes like gasoline, whereas charging huge batteries can take hours. It might seem strange. People in the energy world talk about hydrogen using colors. These colors aren't about the gas. It's always colorless. They're about how it's made. The color code shows if production was clean or dirty. The most common type today is gray hydrogen. It's produced from natural gas, mostly methane, made by steam methane reforming. The process uses heat and pressure to split methane into hydrogen and produces carbon dioxide. That CO2 is usually released to the atmosphere, so gray hydrogen isn't a climate solution. Next, blue hydrogen. Starts the same, from natural gas, but with one extra step: carbon capture. Equipment captures CO2 before it escapes. Captured CO2 is stored deep underground. In theory, blue hydrogen is low carbon, but it's expensive and doesn't capture all emissions. Stored CO2 can also leak over time, a real concern. So, is hydrogen the silver bullet that will solve the climate crisis? Well, the answer is a bit more complicated than a simple yes or no. Hydrogen has the potential to be a huge part of the solution, but it can't do it all by itself. Its real strength is decarbonizing sectors where direct electrification with batteries is difficult. Think heavy industries, steel, cement. These need incredibly high temperatures that are hard to reach with electricity alone. Hydrogen can be burned to produce that intense heat without carbon emissions. Another big use is long-distance heavy transport, container ships, long-haul trucks, airplanes. Imagine powering a massive container ship for 2 weeks only with batteries. The batteries would be enormous and heavy, leaving no room for cargo. Hydrogen can be stored as a liquid or as compressed gas, giving high energy density for weight and volume. That makes it practical for ships, trucks, and planes. Replacing diesel and bunker fuel can cut pollution. Whenever we talk about a new fuel, safety is one of the first things that comes to mind. Hydrogen is a flammable gas, and it's true that it needs to be handled with respect and care. But it's important to remember that the fuels we use every day, like gasoline and natural gas, are also flammable and potentially dangerous. We have spent over a century developing technologies and safety standards to handle them safely, and we can do the same for hydrogen. In fact, industries have been safely producing and using huge quantities of hydrogen for many decades in refineries' chemical plants, so we have a lot of experience to build on. Hydrogen has some unique properties that affect its safety profile. One key characteristic is that it is extremely light, the lightest element in the universe. If hydrogen leaks in an open area or in a well-ventilated area, it will rise and disperse into the atmosphere very quickly, moving up and away from people and moving away from potential ignition sources. This is quite different from gasoline vapor, which is heavier than air and can pool on the ground, creating a lingering fire hazard. Show diagram: hydrogen leak rises versus gasoline pooling. After exploring the science, the uses, the challenges, what's our final takeaway on hydrogen? Not a miracle cure won't end climate change overnight. Powerful and versatile energy carrier has specific strengths and weaknesses, not a replacement for everything, a key player in a clean energy team. Not a hydrogen economy, rather part of a clean energy economy. Electrification, renewable energy, enhanced efficiency. Best for hard-to-abate sectors. These are the toughest parts to cut emissions. Steel making, ammonia production, long-distance shipping, aviation. Hydrogen enables deep decarbonization here where batteries or direct electricity fall short. Verdict: balanced but optimistic. Burning hydrogen with oxygen makes water. That's the key. It's a chemical reaction that could power our world without warming it up. For decades, we've burned fossil fuels like coal, oil, and gas. Those release huge amounts of carbon dioxide into our atmosphere. This is changing our planet's climate in obvious ways. Hydrogen offers a different path. It lets us store energy from renewables like solar and wind. Those sources aren't always available. We can use that extra clean electricity to make hydrogen through a process called electrolysis. We'll get into that more later. Then, we can store that hydrogen in tanks and turn it back into electricity whenever we need it. That makes the grid more reliable and lets us use more renewables. It could also heat homes and buildings, replacing natural gas and making cities cleaner and healthier. For small cars, lithium-ion batteries are often more efficient. But for long-distance, heavy loads, semi-trucks, ships, airplanes, hydrogen starts to make a lot more sense. It packs more energy into less weight than batteries do, which is critical for these applications. Hydrogen isn't here to replace everything else. It's a powerful tool we can add to our clean energy toolbox to be used for the right jobs. But be realistic. Hydrogen has limits. Efficiency is a major challenge. Make green hydrogen, electricity, electrolysis to make hydrogen, compress or liquefy it, transport it, convert it back in a fuel cell. Energy is lost at each step. For passenger cars, it's often better to charge batteries directly. So batteries likely win for cars, hydrogen for bigger uses. Cost and infrastructure are other hurdles. In late 2025, green hydrogen is still much pricier than gray hydrogen from natural gas. We need pipelines, storage tanks, refueling stations. Building all this takes heavy investment and time. Hydrogen isn't a quick fix. It's a long-term strategy developed alongside other solutions, expanding renewables, improving building efficiency, and better batteries. It's one piece of a very large puzzle. The real star is green hydrogen. It's the one tied to a clean energy future. Green hydrogen is made by electrolysis. Electrolysis uses electricity to split water, H2O. That produces hydrogen and oxygen. If the electricity comes from solar or wind, the whole process is carbon-free. The only byproduct is oxygen. That makes green hydrogen a truly clean energy carrier. It's the gold standard. Other colors exist. Brown or black hydrogen from coal, very polluting. Pink hydrogen uses electricity from nuclear power. These color labels help scientists, policymakers, and the public understand climate impact. Today, almost all hydrogen is gray because it's cheapest. The big challenge is making green hydrogen cheaper and more available. As we build more solar and wind farms, green hydrogen costs should fall, helping it become a major player in our energy system. The flame from a hydrogen fire is also nearly invisible in daylight, which requires special sensors for detection. On the other hand, hydrogen's tiny molecular size presents its own challenges. Hydrogen atoms are so small that they can leak through materials that would easily contain other gases. This means that pipes, valves, and storage tanks for hydrogen must be built to incredibly high standards using special materials. Another issue is that hydrogen can, over time, make certain types of steel brittle. Hydrogen embrittlement. Engineers must carefully select materials that are resistant to this effect to ensure the long-term integrity and safety of the infrastructure. Modern hydrogen tanks, like those used in fuel cell cars, are incredibly tough, made from carbon fiber composites and subjected to extreme testing. Ultimately, managing the risks of hydrogen is a task for science and engineering. Through rigorous standards, advanced sensor technology, and robust design, hydrogen can be made just as safe, if not safer, than the conventional fuels we rely on today. For example, hydrogen fuel tanks in cars are designed to withstand high-speed crashes without rupturing. Safety protocols for refueling stations are being developed based on decades of experience with other compressed gases. As we build out a hydrogen economy, a strong focus on safety codes and public education will be essential to ensure that everyone can trust and benefit from this clean energy carrier. Not a hydrogen economy, rather part of a clean energy economy, electrification, renewable energy, enhanced efficiency. Best for hard-to-abate sectors. These are the toughest parts to cut emissions. Focus investment on deploying green hydrogen in these areas, most bang for our buck. Not ideal for passenger cars, not ideal for home heating in most places. The future depends on one thing: a massive build-out of cheap renewable electricity. Without abundant solar and wind, we can't make enough green hydrogen. Hydrogen from fossil fuels, even with carbon capture, falls short. So policies that back renewables also back green hydrogen. Cost of green hydrogen is falling, dozens of countries investing billions in scale-up. Hydrogen is an essential tool, not the only tool, but one we can't ignore. Requires careful planning, significant investment, and using it for the right jobs. Deploy hydrogen where it makes sense, push electrification and energy efficiency everywhere else. If we do that, this tiny, abundant element can play a huge, heroic role building a cleaner, safer, sustainable world for everyone. For